In this video, we continue to code our algorithm for Sieve of Eratosthenes. So let's start by finding the multiples that will determine which numbers are and which ones are not prime numbers. I'm going to create a function that will do that. So here, I'll simply create another void function. Nothing is going to be returned. And I'll call it Sieve. And once again, we are going to pass the integer n to it as for the array size, because that will be our upper bound for our loops. Now, the function receives the argument n, like I said, which is the size of the array. Technically, it is not necessary. We could simply use the array.length method to find out the size of the array, but we already have the size calculated. We already added +1 to it, so we can as well use that instead. I think it's a little more elegant than using the array.length. So to find the multiples, obviously we need a loop. We can use a simple for loop, and we can start from index 2 because we know that prime number needs to be greater than 1, so we can ignore 0 and 1. So I'm going to do a for loop with another I equals 2. We'll start from 2 like I said, and I is less than n, and we'll iterate by 1 again. Now within the loop we can perform the search for the multiples. But remember, we only want to perform the search for numbers that are marked as true. We want to simply skip all the ones that are false. In other words, false means that they are not prime. So we can check if the number we are currently looping through, the I index, we can check if that is marked as true. And if it is, we will perform search for the multiples. So to do that, we'll simply do if statement, and we'll check if the number within the all numbers with the index of I, if that's true. You can type equals true, but it's not necessary. If condition always returns true or false, so we'll simply say if all numbers I, and that automatically means that if it is true, then we'll perform the search. So if it is not true, we do nothing. We simply return back to for loop and perform the next iteration for the next number. But if it is true, we can now loop from that number to the number n and check if the number is multiple of I. So we can create another for loop. However, we don't start from 0. We'll simply keep moving forward. So we'll start from c equals I. So as we move through i's, we'll also start with the c. We'll loop until the end, and we'll of course iterate ++. Now this is actually incorrect, and I will explain why and what needs to be done in just a minute. So for now, let's continue with the calculation or the search within our loop. So the goal is to mark all non-prime numbers as false. So we are looking for all multiples, and if we find one, we mark it as false. So basically we are checking a number in our all numbers array, so we can code it as all numbers array. And the index we are looking for is I. However, there's a little twist, because we are looking for the indexes that are multiples of I. So we want all indexes that are I multiplied by c. In other words, the index will be I multiplied by c, because that is the multiple. So if we find one, we'll mark it false, because that means if there's a multiple, then it's not a prime number. But let's look back and see what's happening here. So the first iteration starts with number 2. 2 is unmarked, so we go inside the loop, and if I equals 2, also c equals 2, because c equals I, which is our starting position within the inner loop. So the first index we check is 4, because I multiplied by c is basically 2 multiplied by 2, which is 4. And we mark that index as false, because we found an index of 4 that's not a prime number. Then we go to the next iteration in our inside loop or our inner loop. Now we are looking for 3. I is still 2, but c now equals 3. So we are looking for index 2 multiplied by 3, which is 6. We find it and mark it as false. Next iteration will be obviously 2 multiplied by 4. I is still 2, but we are still within our for loop, and c being iterated by 1, now it's 4, so 2 times 4 is 8, we mark it as false. And this way we continue through all the numbers. Now let's see what happens when we come to C being index of 51. If I equals 2, we look for index 51 times 2, which is 102, but we only have 100 numbers. So the program would crash. That's because our condition within the loop is not correct, as I said. We are not looking for all numbers less than n. What we are looking for are all multiples of I times C less than n. So basically we'll do I times C. So in this case, when we come to 51 times 2, which is 102, the loop does not perform another iteration because 102 is not less than 100, but instead it exits because we checked all the multiples of 2 already, and we go back to our outer loop. Now I will equal 3, and we'll continue the process. So if I equals 3, we start with C equals I. Obviously C equals 3 now because I is 3. And we check for 3 times 3 index, which is 9, and we'll mark it as false. Next, index I is still 3 because again we are within our inner loop. So now we'll check in 3 times 4, which is 12, and mark it as false. Now this one is actually already marked as false from the previous iteration when I equal 2, but for our purposes it doesn't matter. We are only moving forward. But you could optimize this further if you want to and eliminate any duplicate operations to speed up the algorithm. Well, alright, hopefully you now see how the prime numbers are being found, and all that is left is to display them. Now I want to display all the numbers in a matrix, say 10 columns, and once 10th number in a row is reached, we move to the next row. And it's a very simple thing to do. First, I'm going to create a counter variable and initialize it to 0. So after we find all the numbers, we'll display them. And like I said, the first will be declaring the counter and initialize it to 0. And to display the numbers, 10 numbers in a row, we'll simply loop through them in our array, and we display all the indexes that are marked as true because we are only displaying the prime numbers. So we'll do our standard for loop, but again, we'll start from index 2. Basically, it's going to be the same as this. And to display the numbers that are marked as true, just like before, we simply check if the number is set to true in our all numbers array. So we'll do an if statement just like before, and if the all numbers with the index of I, if it's true, then we'll display the number. So to display the number, I'm simply going to output it to a console, and after I display the number, I will also add a space so they are not all cramped together. And I'm displaying I plus a space. And since we only want to display 10 numbers in a row, we need to keep track of how many numbers are already displayed. So now I need to increase the counter by 1 after each time the number is being displayed. And all that is left now is to check if we are at the end of the row. To do that, we can simply check if the counter equals 10. Because if it is, we can now move to the next line printing the carriage return in the console. Carriage return is the /n. So once this executes, the cursor moves to the next line. So after the if statement, I'm going to create another if statement, and I'm going to check if the counter equals 10. And we'll simply print or output the carriage return, which is the /n. And once we reach 10, we need to reset the counter back to 0. That's because we reach 10 numbers in a row, we move to the next line, so now we calculate another 10 numbers. Alright, so this is all the code we need. All that is left is to call the Sieve function. So I'm calling it obviously from my main method, and I'm passing the array size to it as an argument. So let's run it and see if it works. So here's my initial screen. Please enter number n. Let's do 100. And here's all my prime numbers in 10 numbers in a row. So 2, 3, 5, 7, and so forth to 97. So let's do a little higher. So let's do 1000. And you can see here's my little matrix of the prime numbers from 2 all the way to 1000, which 997 is the largest prime number in that range. So this is our Sieve algorithm. Like I said, there's definitely room for optimization, But we do have a working algorithm, and hopefully you understand how it works and also why it works. So thank you for watching, and I'll see you in the next video.